Good day, everyone! And every two, and every three! Are you ready to learn something new? Come on, get ready and let's pack up. Because now, we are going to explore about the speed of light. How long will our journey take us? What are you waiting for? Let's go!
Set, pair.
So, let us define first what is an atom and an electron. So, what is an atom? Atom is the building block of matter in the universe. And what is an electron? While electron is a subatomic particle that has a negative electric charge.
So first, what is a particle? A particle is a tiny pieces of matter that make up everything in our universe, including the atoms and molecules. So these electrons can relate to light. Electrons can relate to light by absorbing or emitting the photons, which are the particles of the light. So this interaction can lead to phenomena just like the photoelectric effect or the emission of light by certain materials.
In the aspect of light, waves refers to the oscillations of electric and magnetic field as light travels through the space. Light can behave both as a particle and as a wave, which is one of the fascinating aspects of quantum mechanics. In conclusion to the dual nature of electrons, which are the particle and wave, electrons can behave like particles with definite positions, but they can also behave like waves, exhibiting interference patterns. This duality is a cornerstone of quantum mechanics, and it continues to fascinate and challenge scientists to this day. So, in short, when an electron moves, it can be considered moving as a wave and as a particle both at the same time.
Transmission. Transmission refers to the process by which light passes through a substance or medium, such as air, water, or glass, without being absorbed or scattered. In other words, it's the ability of a material to allow light to pass through it. Refraction. Refraction is the bending of light as it passes from one medium to another, like pencil to water or glass. This bending happens because light changes its speed when it moves from one medium to another, causing it to change direction. This change in direction is due to change in the optical density of the mediums. Absorption. Absorption occurs when light is taken in and converted into other forms of energy by a material. When light encounters an object, some of it is absorbed by the material, causing its energy to be converted into heat or other forms of energy, depending on the properties of the material. This is why dark-colored objects feel warmer in sunlight. They absorb more light and convert it into heat energy. Reflection. Reflection is the bouncing back of a light rays when they encounter a surface that does not absorb them. When light hits a smooth, shiny surface, like a mirror, it reflects off the same angle if it hits the surface, obeying the law of reflection. This is why you can see your reflection in a mirror or why light bounces off water, making it look shiny.
White light is passed through a glass prism. It splits into different spectrum of colors, which is violet, indigo, blue, green, yellow, orange, and red. And this process of light splitting into its constituent color is termed as dispersion. In short, dispersion is the separation of white color into several colors or wavelengths. Do you even wonder why is our sky color blue? Next is scattering of light. Scattering of light is the phenomenon in which light rays gets deviated from its straight path, striking an obstacle like dust, gas molecules, water vapors, and many more. To explain it more specifically and more clearly, we have an example. We can think that the sunlight contains white light, and that white light contains many colors. The Roy G. Biv, such as red, orange, yellow, green, blue, indigo, and violet. In this scenario, the sunlight acts as a wave.
In this example, we have a material of a container with water as the Earth's atmosphere. The milk as other particles in the atmosphere. And the flashlight as our sunlight. First, we need to put the milk into the water as the mixtures of Earth's atmosphere and the other particles in the atmosphere. In this demonstration, the light of the flashlight flows from the top and to the bottom of the container. Now that the particles that we mix with water and milk filter the color and it only scatters the blue color, which is more visible compared to other colors. This is exactly what happens every morning and noon when the sun is in that sky. Now, when we put the flashlight on the other side of the container, we notice that it turned into yellow or orange color. It is because the light of the flashlight passes through more particles of the water and milk mixture. Because of this, it filters the true color of light and shows the dominant color yellow or orange with low frequency and low wavelength. This is what happens every time the night approaches or the sun sets.
It's trivia time! So now that we understand the behaviors of lights, let's move on to the theory of light of some philosophers to have some insights. People that do not believe that light was made up of small particles but has mass too. And Huygens believe that light is made up of vibrating waves perpendicular to the direction it travels.
That's right. And you know, in 1803, Thomas Young studied the interference of light wave using the double slit experiment. And they also know that Francisco Grimaldi is the one who discovered the diffraction and the term itself.
Aha! That's right!
Now that you finally gained insights, until next then, see you!
Bye-bye!
And that's where fun and new knowledge ends today. I hope we learned something about what we mentioned about the dual nature of electrons and the interaction of light and
The theories of some of the aforementioned philosophers on how their theories works based on our experiments today.